If I want the gene in there to be activated, which says nerve cell, and I want this powerful muscle that you see over here activated over here, which says muscle cell, and I want the one that says nerve cell switched off, if I have two sets of lights, one there and one there, I want those lights on, those lights off. What must I have in the back? A switch. How many switches? 2. All right, so I need a switch. I need a switching gene. We call them promoter systems. They're far more complicated than this. Hello, you're switched on, you're switched off. Hello there, you're switched on, you're switched off. The original cell that didn't have the 2 cells, did it have to have the switch? Where does the switch come from? You have 2 choices. Boom, little house, or design. One of the 2. That's your choice. So can you see that as you get more and more complicated, you need one enormous amount of faith? You have to believe that an explosion going through a junkyard will really assemble a jumbo 707. You have to believe it. Or you have to believe in a designer. That's what it really looks like at the gene level. Not enough. What's the point of having a nerve cell up here and a muscle cell over here if they don't work together? Mustn't I be able to say, arm, lift yourself up, boom? Yes or no? All right. So I need a gene, structural genes up there, which say, you are a nerve cell, you are a muscle cell. I need 2 promoters, that's the switches. You're switched on, you're switched off. I need genes controlling the physiology, how to develop so that the one grows and works properly. I need genes controlling the embryology, that they work together. Where do all these extra genes come from? You have 2 choices. Chance or design. Now, let us say we're actually making something. Natural selection normally cuts off the extremes. Now, for selection to take place, I must have how many things to choose from? At least 2. What's the point of having a selection if there's only one object to choose from? Are you with me on this? If I want to go and vote for a political party, as I've said before, and there's only one party standing, is there any point in going to vote? No. You need 2. So, in order for natural selection to start working, you actually have to have 2 products there, 2 aeroplanes. Now I can ask the question, which one of these 2 aeroplanes flies best? Are you with me? All right. So, did natural selection make anything? No, didn't make anything. It can only work with what is there. The 2 aeroplanes must be there. Where did the 2 aeroplanes come from in the first place? You have 2 choices. Chance or design. Now I have 2 aeroplanes, and I'm going to fly. The one goes, and the other one goes. Natural selection has favored the one at the expense of the other. Is that right? All right, so let's take the example of the peppered moth. There's the light moth and the dark moth. You put the light moth on a light background, it disappears, the black one stands out. You do the reverse, the black one disappears, the white one stands out. Eventually the birds will eat the light one. If this carries on long enough, what happens to the light one eventually? It becomes extinct. Now comes my bomber question to you. Natural selection is the god of evolution. It's the one that makes bigger and better and greater than ever before. Is that right? Now it chooses between 2. One is favored, the other one goes extinct. What has it done? Has it added something or taken something away? Are you sure? Let me repeat that. Has it added something or taken something away? It's taken something away. How can a mechanism that makes less and less end up having created more and more? Does it make any sense? It doesn't make any sense. So if you look at the fossil record, there was far more there in the past than there is at present. Is that right? And are we losing species every single day? Yes or no? So natural selection is doing such a good job that soon there'll be nothing left. It's not a good way of getting more and more. So we see that in the past, like these trees, there were far more variants than there are today. So where does everything come from? It comes from chance or design. That's your object. That's it. You have to choose that. So let's take the dog. The Great Dane, from the Papillon down to the Chihuahua, this shape, that shape, this shape, that shape, all the body shapes, all the colors of the wild dogs, all these ear shapes. We know this is one species. We have Afro-style hair, we have white hair. If you take the Afghan, we have blonde hair. We have every hair color, we have every hair type, we have all these things, and it's wild type wolf. We know that, it's one species. So all the genes that make all this variety, where do those genes come from? You have two choices. It's genotype. Chance or design. That's it. So every single allele that we have, all this variety that we have, it's chance or design. These snails over here, every single one of them was classified as a different species in the past. Today we know they're one species, just different genes expressed at different times. Butterflies come with different shapes and sizes and colors and different seasons. Same species, different genes activated. Where did those genes come from? So you can have one butterfly of the same kind, looking like this one season and like that one season. Where did that come from? Boom, little house or design. That's your probability. This creature over there, this pigeon, built-in variety is massive to small, dark to light, strange to weird, all shapes and sizes, built-in variety. This beetle, black to white to large to small. This beetle, black to white to large to small, one species, the quagga. Today, we know that this quagga, which is an extinct animal, is actually not extinct at all. They found a pelt in the museum, and they found some blood vessels, sent it to the United States, did DNA analysis, and they found that the DNA is identical to the plains zebra living today. So they started a breeding program, and they're breeding the quagga back. Was it extinct? Yes or no? No. It just was a different gene expression. If you take this ladybird, it's black in the spring, and it's got the red and white and the red and black structure in the fall. Two species or one species? One species, different sets of genes. All of these are one kind. If you take the pocket mouse, white in a snowy background, dark on a rock background. Genes that oscillate from white rabbit in the winter to dark rabbit in the summer. Different expressions of the genetic potential in that animal. Also mountain lizards to coastal lizards, all these changes. We're dealing with genes. Boom, little house, boom, little house, boom, little house, or design. That's your choice. Anything that changes the genotype to give more variety must also come about by chance. And the process that is used is fertilization. So there we have it. Fertilization. Two creatures producing offspring by mixing their genes. Now I want you to think about it. Just shake your heads. Wake up. Are you awake? All right, think. Natural selection works on what is there. Is that right? The babies have to be there. The children have to be running around. Question. Reproduction increases the variety. But natural selection only works once the babies of this process have been produced. So how did sexual reproduction, which just mixes genes, that's like rewriting the book a little bit. How did it come into existence? You have two choices. Chance or design. Now it's getting really phenomenally amazing. To run this by you, we have 46 chromosomes, is that right? 23 are from dad, 23 are from mom. They go and lie in homologous pairs like that. And during meiosis, the one can go this one, the other one can go that one, or the other way around. We call that random sorting. Just from that, I can get 2 to the power of 23 times 2 to the power of 23. That's 80 trillion different offspring. Can you imagine that? I can produce 80 trillion different children just from that